Welcome to Chanan Academy. In today's class, we are going to be discussing indices. Indices is the plural form of index. So what is an index? Suppose we are given a number, say 2 times 2 times 2 times 2. Now, this number is quite in a larger form. For us to be able to write this in a shorter form, we can as well count the 2. Say this is 1, this is 2, this is 3, and this is 4. So we can write it to be 2 raised to the power of 4. So this representation, where the 2 is the base and the 4 is known as the index. So in the general form, we can say if we have a raised to the power of n, a is the base and n is the index. So with this knowledge, we can then say if we have 4 multiplied by 4 multiplied by 4, this can be equal to 4 raised to the power of 3. Don't forget 4 is the base and then the 3 is the index. Alright, so what if we have 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3? Please drop the answer to this in the comment section. Alright, so in a short form, we can say indices tells us how many times a number is multiplied by itself. Don't forget, if we have a raised to the power of n, the n is known as the index. But however, sometimes you can call it the power or the exponent. And then the a is the base. Laws of indices. The laws of indices makes calculation easier for us. And the first law we are going to look at is the multiplication law. Now take note, same base you had the indices. Base don't add the indices. Alright, so let's show that. So if we have a raised to the power of n multiply by a raised to the power of m, this is equal to a n plus m. A and a are the base, and then n and m are the index. So when we multiply them, we add their power. For example, if we have 2 raised to the power of 3 multiplied by 2 raised to the power of 4, now this is going to give us 2 raised to the power of 3 plus 4, and this is going to be 2 raised to the power of 7. Alright, now if we have a raised to the power of n multiplied by b raised to the power of m, now this cannot be added. You just leave it like this. This is the answer. Now for example, if you have 2 raised to the power of 3 multiplied by 3 raised to the power of 2. Alright, so the second law we'll look at is for the division of powers, same base, you subtract the indices. Different base don't subtract. So that means that if we have a raised to the power of n divides a raised to the power of m, which is the same thing as a raised to the power of n over a raised to the power of n. Now this is going to be equal to a n minus m. So let's take an example. Suppose we have 2 raised to the power of 3 divides by 2 raised to the power of 2. Now this is going to give us 2 raised to the power of 3 minus 2, which is then going to be equal to 2 raised to the power of 1. Alright, so the next law we are looking at is called the power of power. Now suppose we have a base raised to an index and it has another index outside. Now this is going to be equal to a, you're going to multiply the powers, so which is n multiplied by m. So let's take an example. Suppose we have 2 raised to the power of 3 raised to the power of 2. Now this is going to be equal to 2 raised to the power of 3 multiplied by 2, which is going to be 2 raised to the power of 6, and this is going to be equal to 64. All right, so let's look at the next law. Power of a product. Now suppose we have a base a, b multiplying each other raised to the power of n. Now you raise the factors separately. Now so you are going to have a raised to the power of n and then b raised to the power of n. This is going to be our answer. So let's take an example. If we have 2 multiplied by 3 raised to the power of 2. Now this is going to be equal to 2 raised to the power of 2 multiplied by 3 raised to the power of 2. And then this is going to be 4 multiplied by 9. And this is going to be equal to 36. Alright, let's use the board maths to check if this is correct. Now 2 multiplied by 3 is 6 raised to the power of 2. Now that means 6 multiplied by 6, and this is also equal to 36. So you see it's the same thing. Alright, so let's check the next law. Power of a quotient. If we have a over b all raised to the power of n, it is still the same thing as a raised to the power of n over b raised to the power of n. So let's explain this with an example. If we have 2 over 3 raised to the power of 2, this is going to be equal to 2 raised to the power of 2 over 3 raised to the power of 2, which is going to be equal to 4 over 9. And this is our answer. Alright, let's look at the next one. Zero index. If we have a raised to the power of 0, this is equal to 1. Now let's take an example. If we have 127 raised to the power of 0, the answer is 1. If we have 3600 raised to the power of 0, the answer is still 1. Alright, so let's look at the next one. Negative indices. A negative index means a reciprocal. So if we have a raised to the power of negative n, this is going to be equal to 1 over a. The negative n will become positive n. Okay, so let's take an example to explain this. If we have, suppose we have 2 raised to the power of negative 3, this is going to be 1 over 2 raised to the power of 3, and this is going to be equal to 1 over 8. So this is our answer. Alright, take note. If we also have a over b, all in brackets, negative n, this is going to be equal to b raised to the power of n all over a raised to the power of n. And if you have 1 over a raised to the power of n, negative n, it is also equal to a raised to the power of n. So whenever you have a negative index, it is always a reciprocal. Let's check the next one. Fractional indices. Now suppose we have a raised to the power of 1 over n. This is equal to the n roots of a. For example, we have 25 raised to the power of 1 over 2. This is going to be the square root of 25, which is 5. And also, if we have a raised to the power of n over m, this is going to be equal to the m root of a raised to the power of n. And that is if we have 64 raised to the power of 2 over 3. This is equal to the cube root of 64 raised to the power of 2. Now the cube root of 64 is 4 raised to the power of 2. And this should be equal to 16. So this is our answer. Alright, before we go into some examples, let me quickly explain something that is a bit confusing for some students. So if we have a raised to the power of n plus a raised to the power of m, this is not equal to a raised to the power of n plus m. Now take note of this sign. It is plus. This can only be true. This can only be true if this sign is multiplication. Take note of that. For example, we have 2 raised to the power of 2 plus 2 raised to the power of 3. Now this is not equal to 2 raised to the power of 2 plus 3. So this is not equal. All right, so now we're going to go straight to take some examples using the indices law. So the first example, we're asked to find the value of 81 raised to the power of 3 over 4. Now from the indices law, we have that if we have a raised to the power of n over m, this is equal to the m root of a raised to the power of n. Now from this case, we can see that a is 81, and then the n is 3, then the m is 4. So we have 81 raised to the power of 3 over 4, which is equal to the fourth root of 81 in brackets raised to the power of 3. So the fourth root of 81 is 3, and raised to the power of 3. So 3 raised to the power of 3 is going to be 27. So the value for 81 raised to the power of 3 over 4 is 27. Alright, so let's go to the next example. So we're asked to evaluate this expression. So solution. The first thing we need to take note of is this 2 raised to the power of 0. And from indices, anything raised to the power of 0 is 1. So we say 2 raised to the power of 0 is 1. So we have 1. And then also from indices, 4 raised to the power of negative 1 over 2 is going to be equal to 1 over 4 to the power of 1 over 2. Now, take note, 4 raised to the power of half is the same thing as the square root of 4. So that means we are going to have that this is equal to 1 over the square root of 4. And the square root of 4 is 2, so we have 1 over 2. So from our question, this then means that if 2 is 1, then we have plus 1 over 2 bracket square. So this is what we have as a question. So let's come down. We have 2 raised to the power of 0 plus 4 raised to the power of negative half, all in bracket raised to the power of 2 is equal to 1 plus 1 over 2, all in brackets raised to the power of 2. Now this is then equal to, now we solve the bracket, so we have 1 plus half is going to be one whole number, 1 over 2 raised to the power of 2. So let's make this to become an improper fraction. Becomes 3 over 2 square. This is then equal to 3 raised to the power of 2 over 2 raised to the power of 2, which is equal to 9 over 4. So this is our answer. Alright, so let's move on to the next example. Alright, so we're asked to simplify this expression. Let's try to break each of the numbers. So now look at this 25. Now this 25 can be expressed as 5 raised to the power of 2, because 5 raised to the power of 2 is also 25. So we can put it in a bracket and say x minus 1. Also, if you look at 125, 125 can be written as 5 raised to the power of 3. So we can also put this in bracket and say x plus 1. Now, let's put that down to solution. So what we are going to have now is 5 raised to the power of x multiplied by 5 raised to the power of 2, all in bracket x minus 1 over 5 raised to the power of 3, all in bracket x plus 1. Okay, from this point, we can open the bracket. So let's open each of the brackets. This is then going to be equal to 5 raised to the power of x multiply. Now, when we open the bracket, we're going to multiply the power. It becomes 5 raised to the power of 2x minus 2 all over 5 raised to the power of 3x plus 3. Good. From this point, we can then apply the indices law that says whenever we find the multiplication sign, we add the power. So let's do that to the numerator. So then we have 5x plus 2x minus 2 all over 5 raised to the power of 3x plus 3. This is then equal to, if we simplify the power, we're going to have 5 raised to the power of 3x minus 2 all over 5 raised to the power of 3x plus 3. Now, we can also apply the indices law, the division of power in this case. So we are going to have 5 raised to the power of 3x minus 2 minus open bracket 3x plus 3. Now, This is then equal to, now if you open the bracket using the negative, you are going to have 5 raised to the power of 3x minus 2 minus 3x minus 3. It is then equal to, if you simplify the power, we're going to have the 3 is going to cancel out this 3, and then minus 2 minus 3 is going to be minus 5. So this is raised to the power of minus 5. This is then equal to 1 over 5 raised to the power of 5. This is our final answer. So we have to simplify this expression. Solution. So from the indices law, we have that a raised to the power of 1 over n is equal to the n root of a. Now we can apply this law in this same question. So let's do that. So this is going to be equal to brackets 27x raised to the power of 9 all over 8 all in bracket 1 over 3. So this is how the question is going to look. So let's start from there. So we have that 27x raised to the power of 9 all over 8 bracket 1 over 3. 27 can be expressed as 3 raised to the power of 3, and then 8 can be expressed as 2 raised to the power of 3. Okay, so that means we are going to have 3 raised to the power of 3 x raised to the power of 9 all over 2 raised to the power of 3 all in bracket 1 over 3. We are just following the indices law to break down everything. So now let's open the brackets. We're going to have 3 raised to the power of 3 bracket 1 over 3, then x raised to the power of 9 bracket 1 over 3 all over 2 raised to the power of 3 bracket 1 over 3. Okay, so now this is equal to 3. So we multiply the power. 3 multiplied by 1 over 3, we are going to have 3 over 3, which is going to be 1. So 9 multiplied by 1 over 3, we are going to have x raised to the power 9 over 3 over 2. Now 3 multiplied by 1 over 3, we are still going to have 3 over 3. If we simplify the power, we are going to have 3 raised to the power of 1, which is same thing as 3, and then x raised to the power of 3 over 2. And this is our answer. Thank you. We have come to the end of the class. Please do not forget to hit the like button, subscribe to the channel, and also drop your comment in the comment section. If there's any topic you would like us to talk about, drop it in the comment section. See you in our next class. Bye for now.